Okay, the new set of identities that we're going to discuss today is the compound angles identities. Means how you can convert a sine of, for example, 4x into expression with sine and cosine for 2x. Okay, so and the compound angles are quite useful to reduce the angle size. So for the four identities that we're going to discuss is sine a plus b equal cosine a. Oh, sorry. Yeah, it doesn't matter. Oh no. Sine a cosine b plus cosine a sine b. And then we have obviously the minus. It's the same minus. That's the sign. So if you've got a sine plus, then you can convert them into those two signs, separate the angles. Okay, and then we've got obviously the cosine. So cosine a plus b equal cosine a cosine b plus, sorry, that's opposite sign, minus, always in the cosine is the opposite sign, sine a sine b, and cosine a minus b is the same as cosine a cosine b plus sine a sine b. So you can see in the cosine the signs are different, but in the sine the signs are the same. Now you don't have to memorize this, it's all on your formula sheets, but you just need to know how to use them, where to use them, and why you need to use them. Okay, now the other compound angles you've got, so that's sine cosine, the other compound angles is the tan. So obviously, because remember we have three trig ratios, so the tan, white and black, tan a plus b, slightly harder, it's tan a plus tan b over 1 minus tan a tan b, and then you have the tan a minus b equal tan a minus tan b, then this one will be 1 plus tan a tan b. Okay, so that's tan, that's t, not plus, looks like plus. Okay, tan a. So you notice in here also there is a pattern, the signs, the top signs are the same, and obviously the bottom signs will be the different one, opposites always. Okay, but again, you don't have to memorize them, they are on your formula sheet, you can just start using them. They are quite useful to simplify the fractions, sorry, not fractions, the expressions. So for example, you could have something like this, cosine pi minus x. Okay, so you can apply the compound, and why it's useful, because the cosine pi is a value, so you can simplify the terms that you've got. So to work on that one, cosine pi minus is the same as cosine, I'm just going to use it in a different color, cosine pi cosine x plus opposite sign sine pi sine x. Now cosine 180 is -1, so that's why it's negative cosine x in here, and sine 180 is 0, so that will remove the whole thing, so that's 0, this is -1, and that's why the final answer is negative cosine, so that you can see that you simplified the expression. We can have one more examples. Let's try the tan. Theta plus 90. So tan theta plus 90 is the same as tan theta plus tan 90 over 1 minus opposite sign tan theta tan 90. Now tan 90 is infinity, so you can't substitute in tan 90 instead of, like, put instead of tan 90 infinity, because you can't substitute infinity. So the best way is divide everything by tan 90, the expression of tan 90. So that's why you'll end up with something like that. We're trying to simplify in here. Why I'm dividing everything by tan 90? So I can get 1 in here. That's plus over 1 over tan 90 minus now tan 90 divided by tan 90 is 1. Okay, anything divided by infinity is 0. So that's why from the numerator this value here is 0. This value here is 1. So that's why only 1 left in the numerator. Over 1 over tan 90, as we said, anything divided by infinity is nearly 0. So 0 here. And this one you can simplify. So it left is 1 over tan negative tan theta. Now 1 over tan, we know it's cot, so that's why you can write it as negative cot theta. So you can see we've simplified it and rewrite the expressions. Right? You can substitute. Means, so for example, if you say tan A equal 1/5 and tan B equal 3/5, find tan A plus B. So obviously you will use the identity. Opposite sign. And now we've already given you the values of the tan, so that's why this is 1/5 plus 3/5 over 1 minus 1/5 times 3/5. And then that gives me 4 over 5 over 1 minus that's 22 over 25. And then simplify, rearrange, you end up with 10 over 11. So from the tan A and tan B, you can find the value of tan A plus B. Okay, we're going to work on some examples that include identities. So let's say you've got this proof that you want to find out. Plus A or equal cosine A plus sine A over cosine A minus sine A. Okay, so you can see in here that proof that's first you've got tan on one side, sine and cosine on the other side, so you need to change this tan into sine and cosine. Another thing as well, here you've got a compound angle pi over 4 plus A on the left hand side. On the right hand side you've got A, so definitely you'll have to use the compound angle identity so you can separate the angles. So we're going to use the left hand side. So I'm going to work on the left hand side. So tan pi over 4 plus A. Tan pi over 4 plus tan A over 1 minus tan pi over 4 tan A. Now tan pi over 4 is 1. So that's why I'll substitute. That's 1 plus tan A over, so 1 minus, and that's 1, so it becomes tan A. Now because now I've reached 1 plus tan A, 1 minus tan A, so the right hand side has sine and cosine, so you need to open up now and to convert the tan into sine and cosine. So I've reached the result of A only now, but I'll have to open up sine A over cosine A over 1 minus sine A over cosine A. So now, common denominator on the top, so that's why I'll end up with cosine A plus sine A over cosine A, flipping the fraction at the bottom, so I'll end up with cosine A on the top and cosine A minus sine A. Now simplify those two, so I'll end up with cosine A plus sine A over cosine A minus sine A, which is proven. That's what I want, the right hand side, which is equal to the right hand side. Thank you.